Hi everyone, today I am going to discuss about the classification of switch on the basis of blocking voltage and direction of flow of current. On the basis of blocking voltage, we have two categories of switches, unipolar switch and bipolar switch. On the basis of direction of flow of current, we have unidirectional switch and bidirectional switch. Now we can discuss what are unipolar switch and bipolar switch. Unipolar switch can block only one polarity of voltage. That's why it's known as unipolar. Whereas the bipolar switch can block both voltage polarities, positive and negative. That's why it's known as bipolar switch. On the basis of direction of flow of current, we have two categories, unidirectional switch and bidirectional switch. Unidirectional switch allows the flow of current in one direction only, either positive direction or negative direction, whereas bidirectional switch allows the flow of current in both directions, positive and negative direction. Now we can discuss different examples and see that how they behave. So first of all, we have the diode. Here we have the diode symbol. First, this one is the anode terminal and this one is the cathode terminal. When anode terminal is greater than cathode terminal, then diode conducts positive current. So this one is positive, this one is the negative, and diode is in the forward condition and it will conduct positive current. And the voltage drop across the diode when it conducting the current is 0 voltage. So voltage drop across diode is 0 voltage. So this one is the unidirection. It only allows the flow of current in one direction, which is positive. If you talk about the second category, here the diode is in the reverse bias condition. The anode is negative and the cathode is positive. Diode blocks the reverse voltage or negative voltage. So there is no flow of current in this direction. No flow of current when diode is in reverse bias condition. So this one is the unipolar because diode blocks only the reverse or negative voltage and it allows current in the positive voltage. Here we have the VI characteristics of diode. When the diode is in forward bias condition, then the current is flowing in the diode. So here we have represented the current, positive current, and when the positive current is flowing, the voltage drop across the diode is 0 voltage. When the diode is in reverse bias condition, it blocks the negative voltage and there is no flow of current. So we have positive current, we have the negative, which is the breakdown voltage of this diode. So this one is the safe operating area of the diode and this represents the second quadrant. So this diode is unipolar, blocks negative voltage only, and unidirectional conducts only current in positive direction. So this is all about diode. Here I have another example, which is silicon controlled rectifier, SCR, which is also known as thyristor. This is similar to diode but having the gate terminal. So when anode to cathode voltage is greater than 0 and Ig is equal to 0, then the SCR is in the off state. Why? Because supplying positive voltage VAK is equal to 0, but we are not providing any gate current which is necessary to turn on the SCR. So SCR is in the off state. It will block positive voltage. There is no flow of current. Here I have shown you the positive voltage at anode and cathode, negative voltage, and Ig is equal to 0, off state. When anode to cathode voltage is less than 0, Ig value doesn't matter. I have applied negative voltage at anode and positive voltage at cathode. Supplying negative voltage, VAK is less than 0. Here this terminal is already in reverse bias condition. Gate current value doesn't matter if you have applied it or not. This terminal is negative, this terminal is positive. This SCR will not block negative voltage. No flow of current. Here is the third condition of SCR when VAK is greater than 0 and we have also applied the gate current to the SCR. Ig is greater than 0. In this condition, when anode is positive, cathode is negative and gate current is greater than 0, then as SCR will conduct positive current. Supplying positive voltage, anode to cathode voltage is greater than 0. Gate current Ig is greater than 0. 0 voltage drop across SCR. Unidirectional positive current. Here is the VI characteristics of the SCR. You can see that when VAK is greater than 0, IG is greater than 0, then SCR will conduct positive current, and at that time 0 voltage drop across SCR. When VAK is greater than 0, then SCR block positive voltage, and when VAK is less than 0, then SCR blocks negative voltage. So here we have only one direction to flow of current, and we have here the SCR have blocked two polarities of voltage. So this one is unidirectional and bipolar switch. Now we can discuss about different transistors. Here I have taken three transistors. One is BJT, the second one is the FET, and the third one is the IGBT. In the BJT, when collector to emitter voltage is greater than 0 and IBE is greater than 0, then there will be a flow of current, and this is the positive current. Voltage drop across switch is equal to 0 voltage when it conducts. So this one is the unidirectional positive current. The same with the case of FET. Here we have the gate, source and drain, and we have applied VDS positive greater than 0 and VGS is greater than 0. Then drain to source a current will flow. So voltage drop is equal to 0 voltage across switch, and this is also unidirectional positive current. If we talk about the IGBT, and we have applied the gate voltage here, and then VCE is greater than 0, then a current will flow from collector to emitter. Voltage drop is equal to 0 voltage, unidirectional positive current. These all three transistors are behaving in the same way. When collector to emitter voltage is greater than 0, but we have not applied any base current, that's why in that condition the BJT will block positive voltage and there will be no flow of current. If we talk about the FET and we have applied VDS is greater than 0 but VGS is equal to 0, it will block positive polarity of the voltage and there will be no flow of current. If we talk about the IGBT and the same condition, that we have applied positive voltage from collector to emitter and there is no voltage at the gate, then it will block positive voltage and there will be no flow of current. Here I have shown the VI characteristics of all these three transistors, BJT, FET and IGBT. When they conduct, when VCE or VDS or VCE is greater than 0, then it will conduct positive current. So we have positive current and we have the 0 voltage when it conducts, and they will block positive polarity when the gate or the base terminals is equal to 0. So these all three transistors are unipolar and unidirectional switches. Now I have another examples, MOSFET and IGBT with parallel diode. Here I have taken the MOSFET, gate, drain and source, and in parallel I have the diode, which is also known as body diode of the MOSFET. Here I have taken the IGBT, collector, emitter and gate, and in parallel, in the anti-parallel direction, we have the diode. When VDS is greater than 0 and VGS is greater than 0, then switch will conduct, the MOSFET will conduct positive current. Positive current, voltage drop across switch is equal to 0 voltage and switch is in the on state condition. The same happens in the case of IGBT. We have the collector to emitter voltage greater than 0 and gate to emitter voltage also greater than 0, then there will be a positive current flowing from collector to emitter. Positive current, voltage drop is equal to 0 voltage. When VDS is greater than 0 but we have not applied any gate voltage here, there will be no flow of current and blocking positive voltage. The same case with the IGBT. We have applied VCE is greater than 0 but we have not applied any gate voltage. No current blocking positive voltage. The third condition is VDS is less than 0. Here the drain is negative, the source is positive. In that condition, diode is in the forward bias, positive anode and the negative cathode, and a negative current will flow through the diode of the switch. So supplying negative voltage, VDS is less than 0, diode conducts negative current, voltage across switch is equal to 0 voltage. And if we talk about the IGBT, the same happens, that we have applied the negative voltage here at the emitter to collector to emitter. Emitter is now positive and collector is negative. This will make the diode in the forward bias condition. So VCE is less than 0, diode conducts negative current. Voltage drop is equal to 0 voltage. If we talk about the VI characteristics of this MOSFET and IGBT in parallel with diode. So when VDS is greater than 0 and VGS is greater than 0, then it will conduct positive current. So we have the 0 voltage here. And when VDS is greater than 0 but we don't have any voltage at the gate side, then it will block positive polarity. When we apply the negative voltage from drain to source, then diode is in the forward bias condition and it will conduct a negative current. So we have positive current when the MOSFET is conducting, we have the negative current when the diode is conducting, and the MOS switch is blocking the positive voltage. So we have this safe operating area for both MOSFET and IGBT in anti-parallel with the diode. Here I have another example in which I have taken diode in series with FET. So this is the FET. We have the gate terminal. I have just mentioned it at A point or B point. So if we are talking about the FET, this will be the source terminal. When VAB is greater than 0 and VGE is greater than 0, so here I have taken this terminal as positive, A terminal as positive and B terminal is negative, and VG is greater than 0, then a current, this diode is in the forward bias condition, and here the gate voltage is also present, so a positive current will flow from this one. Positive voltage supply, VAB is greater than 0, positive flow of current, voltage drop across switch is equal to 0 voltage. When voltage from A to B point is greater than 0 but VGE is equal to 0 voltage, what does it mean? That we have applied this terminal positive, this terminal negative, but we don't have applied any gate voltage here. So there will be no flow of current because this was in the off state condition. Block positive voltage, no flow of current. When VAB, A terminal and B terminal, the voltage across these terminals is less than 0, then the value of gate voltage doesn't matter because here the diode is in the reverse bias condition. Block negative voltage, diode is in the reverse bias condition and there will be no flow of current. Here I have shown the VI characteristics of this, in which diode in series with the FET. From A to B terminal, when voltage is greater than 0 and we have the gate voltage here, then it will conduct positive current and it will have voltage drop 0 here. So this is the condition when gate voltage is there and the positive polarity from A terminal and negative polarity at the B terminal. So this one is the positive current here. The second category is that we have applied the positive voltage from A to B but we have not applied any gate voltage here, then it will block positive voltage. The third category is that VAB is less than 0. Here we have applied negative voltage, here we have applied positive voltage, and then VG value doesn't matter because this diode is in the reverse bias condition and it will not conduct the current. So it will block negative voltage. So this is the safe operating area for this diode in series with FET. So this is all about the classification of switches. I have given you different examples and try to elaborate the unipolar, bipolar, unidirectional and bidirectional switches. I hope you like this video. I hope you have learned something new from this video. If you like my video, subscribe my channel and hit the bell icon.